I think things have got to come up to date in evolutionary biology and recognise that essentially Darwin would never have been a Neo-Darwinian.
Denis Noble, welcome to How the Light Gets In.
I am very happy to be here and delighted to have this discussion with you.
In one form or another, as you've claimed, the idea of genetic determinism, this idea that our behaviour is controlled, can be predicted by the inner workings of our biological makeup, goes back a very long time. You point out that you can find it in Descartes in the 17th century.
You can, that's right, yes.
Why do you think this idea has sort of such a lasting appeal?
I think it has been a big mistake, if I may be philosophical for a moment, of dualism. See, Descartes was a dualist. He dealt with the problem of the mechanics of an organism by saying there must be a spiritual entity that interacts with the mechanics. This was Cartesian dualism. And in a sense, the dualism of the replicator being in communication with and conducting the vehicle is a resurrection of the same kind of problem. We don't need a dualism. The agency of organisms comes from within us. It doesn't come from some ghostly outside. I don't even know what that would mean if I tried to give it meaning. So I think it's fairly easy to see where it comes from, because obviously it has to have some degree of non-determinate function. Otherwise it would be determinate. So what we're talking about is, can there be innovation? Can there be creativity? That's the key question. Now the Darwinian, or rather the Neo-Darwinian answer to that is, well, there is chance, there is stochasticity, but it's not used. It is just simply determining how many breakages, how many changes occur naturally in the genome. And then natural selection comes along and automatically works out which are successful and which are not. And I accept that. Obviously, if that is the way things happen, that's fine. Now, I just reverse that by saying that in addition to that process, organisms can actually go and use the chance. And they're doing that all the time. See, the way our immune systems work shows that. What happens when a new virus or new bacterium or new anything else arrives is, first, the immune system. I'm going to use some anthropological way of saying it, but we all know this has to do with molecular processes. What it does is to try to find out whether it's got a sequence that already can latch onto that virus or that bacterium, in which case it just multiplies those cells. So it's got the feedback there already if it already exists. If it doesn't, it does something quite fascinating. It goes to the nucleus and says, please stop the error correction and allow the breaks to occur. And then we will select out of those the very few that can grab hold of this new virus. That's how the immune system works. Now, what I'm saying is that's general. It happens in bacteria when they resist antibiotics. It happens in cancers where they resist radiotherapy and chemotherapy. What do? They also hypermutate. They use chance to get novelty. And I think that's what organisms are doing all the time. The answer, therefore, I think, to the question, are we creative? First of all, it's obvious we are. How do you get a Beethoven? How do you get an Einstein if we're not? But the question is, can physiologists explain that? And I think they can. If you can bring that stochastic process under some kind of control, you then do the selecting, then you can end up with creativity.
To go back to your claim that this sort of gene-centric or gene-deterministic view is founded on a kind of dualistic picture of the human as divided between the body and something else, do you find that animates even contemporary versions of this idea of the gene-centric deterministic
less
picture?
and less, actually, because I don't want to diminish the reputation of Richard Dawkins. I've acknowledged that many times. his book is clearly the best exposition of Neo-Darwinism we've got. Popular exposition. It naturally sells in millions of copies. But I don't think the great majority of research biologists are any longer following that path in the way in which he laid it out. So I'm sorry to say I think the ground has shifted quite a long way. You see, in the debate we've just had, and he preferred to call it a conversation, I'm happy with calling it a conversation, but in what we've just done, it seems to me that what that showed was that I don't think people like Richard yet know that things really have moved on very rapidly. Did we know a few years ago that there could be tiny particles that can carry RNAs and DNAs to the germline? No, we didn't. That's within the last 20 years. So there is a shift here. It's in principle of enormous proportions, and whether people are waking up to that in the public media, I rather doubt. But they really should, because it has big, big implications.
And what do you see as the main fault of this old picture, the gene-centric, selfish gene, Richard Dawkins, Neo-Darwinian picture of ourselves? What's the main kind of objection that you have to that picture?
Well, the main one I've got is actually a health and welfare problem. We've spent literally billions now in the world sequencing genomes. Now, I'm not denying the importance of the genome sequencing. It has clearly given us the possibility of establishing trees of life and so on as we compare the genomes of different species. That is brilliant. That's good fundamental science. But I'm a physiologist. I teach medical students. From the point of view of what was promised 20 odd years ago in relation to cures for cancer, cures for diabetes, cures for Alzheimer, cures, you name it. There was going to be these cures coming from the sky almost as we got to know which genes caused which. What have we found? The association levels are quite tiny. Now, physiologists like me, seeing that data, says, but we know why. I mean, the experiment that I described in the debate is very obviously illustrating that. We found a major protein that contributes to the rhythm of the heart, how frequently it beats. We know it contributes about 80% of the current that generates that rhythmic frequency. Knock it out with a blocker of that protein or knock the gene out, what do you find? A very modest change in frequency. Now, that doesn't mean that it didn't contribute 80% of the functionality. We know it did. We measured it. What it means is that another mechanism kicks in, and we know what that was. So we've been able to show that from a physiological point of view, the association scores don't really tell us very much. You can even have an association of 0 for a gene that is actually functional. Now that's striking. But what that means is, just reading your genome, you won't know that. You won't even see that. So I think the big issue for me is, when are we going to wake up to the fact that we've spent 20 years now sequencing as many genomes as we can? The output, as promised, simply hasn't appeared. If we appreciate why that happened, why that failure happened, we can then shift to a better way of doing it. And we know what that was. Before genome sequencing, what we did was to look at the high-level organization of the system, the living system, locate what was going wrong there, and then work down to find what you might do at lower levels with a drug, or any other kind of treatment for that matter, to put it right. And that works much better than trying to go the other way, because going the other way, the space for possible molecules and possible effects, and even more possible combinations of effects, because those complex diseases are going to require combinations of treatment. There are too many. You can't do clinical trials on all of those possibilities. It's just far too expensive. So I think we just need to take a different approach to research, medical research, to try to benefit from the human genome sequencing in a way that's different from what they originally promised. The new medications haven't fallen out of the sky. We now need to take up the pieces and work out why that was the case. I think I've already explained that. And then what do we do about it, and how do we do a better way of getting healthcare sorted out? Because it's urgent to do so. We've got aging populations that are going to swamp our health services. This is really urgent.
So the previous picture in your mind suffered from this almost reductionist impulse, that
Yes.
everything was reduced to the level of the gene, and once we found what genes were for each disease, we could then treat it. But as you say, there isn't actually a gene for most things.
There isn't a program there, I'm afraid. You see, I'm a programmer. I know how to write if, then, else, and if so, then that, and so on. You know, you can do that endlessly. It's what programming does. There is no such program in the genome. You look there and try and find it, you won't find it. What you've got is a series of switches, because it is true that each sequence that can be used to make an RNA or protein has a place where it can be switched on or off. Sure. But that's the switch. It's not the if-then logic. The logic is not there.
You've said that this approach is sort of Neo-Darwinian, and in a way you were hinting that it goes against the kind of fundamental tenets of Charles Darwin himself.
Absolutely so.
How do you see the difference between those two? What was Charles Darwin's view, and how did it get distorted by Neo-Darwinianism?
Yes, I think what Neo-Darwinism did was to take his initial, the discovery for which is initially rightly respected enormously, which is natural selection, which is the key element in The Origin of Species and in the joint papers he did with Wallace at the previous year, 1858. So, rightly, Darwin is praised for that. But he was a much more nuanced thinker about evolution. He went on worrying about this all the way through his life. First, in The Origin of Species itself, he already includes use and disuse as a mechanism of evolution. Even the great modern synthesist Ernst Mayr, in his big book on biological thought about 30, 40 years ago, at the time of the centenary of the Origin of Species, he wrote, you know, in Darwin I can see 12 places where he acknowledges Lamarckian mechanisms. So it wasn't absent in 1859, but by 1868 he formulated a theory which he then went on for the next 10 years of his life to try to prove. He was that devoted to it. Now, his theory was very simple. It was that the use and disuse in the body can get communicated to the germline. How can it do that if there aren't particles that do that? He couldn't see them. So he admitted at that time, you find that in his 1868 book, he says this is a guess, this is a hypothesis. We've now found them. And they are the tiny particles that cells all over the body are pouring out all the time. I mean, when Richard told me during the debate, you know, it would need all of this information to be well, it is transmitted. So I think things have got to come up to date in evolutionary biology and recognize that essentially Darwin would never have been a Neo-Darwinian. He would not have accepted the Weissman barrier. Otherwise, he wouldn't have developed his theory of gemmules to explain how information could go from the soma to the germline. He would have never accepted the idea that natural selection was the only mechanism, and he says that specifically. So I think if he'd lived to hear Weissman giving his famous lecture in 1883 on the isolation of the germline, he died in 1882, so he couldn't, but if he'd lived to it, I think he would have said, no, you're wrong.
What's the alternative picture to this sort of genetic determinism? You've used the metaphor in the past of thinking of genes not as a code, as you said, but as a kind of musical score.
Yes.
And as a score that can be interpreted in various different ways. Can you tell us a little bit more about the way you think about this?
Yes. Well, I am, as it happens, a musician. I actually give a big concert tomorrow in Oxford in the Sheldonian Theatre. But no, I've obviously taken from my musical side of my life this metaphor for a very good reason. If you look at a score of Bach, Beethoven, Mozart, whatever you want to take, and you look at different orchestras and different soloists interpreting those scores, what stands out a mile to a musician is the differences. Of course you can recognize the same notes are there, but the interpretation is so different that one has always to say there's this style of playing Beethoven, there's that style of playing Beethoven. The same thing can be said about Bach. And I think the answer is that the analogy is that with the same notes you can play totally different music. And the same is true for genes. With the same genes you can play very different behavior. For example, if I'm selfish, I have my selfish characteristic at a time when I have the genes that Denis Noble has. When I am altruistic and very kind to people, I have exactly the same genes. My genes haven't changed between being selfish one day and being altruistic the next day. I naturally use the same genes. So genes can't be responsible for my selfishness. I'm responsible for my selfishness.
So what is the agency here? Where do we locate it? Who's doing the interpreting of the musical score here?
The organism is the source of the interpretation. Now the big question there is, how do you explain that without recreating a duality? How do you get to that without having to make Descartes' mistake? Descartes' mistake was to suppose there's a kind of other entity, non-material, a soul, a spirit, whatever you want to call it, that interacts with the mechanics, as it were, because he actually thought that other animals, apart from humans, were indeed mechanisms. So now, interestingly, most evolutionary biologists who are the Neo-Darwinian persuasion tend to say, well, humans are also. Now that's difficult because we seem to feel that we're not. But put that to one side. The big question is, how can you get creativity without having to have something up there that injects it into you? You know that lovely painting of the fingers pointing, you see, and Adam gets, as it were, activated by the finger of God. We don't need that. I'm not saying whether people who believe that are right or wrong. I'm leaving that to them. But what I do think is you don't need that because the organism has that ability already. The reason is simply because it can use the chance events that occur in its molecular mechanisms. There's where the creativity comes from. Then the question is, what emerges from that you want to keep and what do you want to reject? It's very simple.
It sounds like what you're saying is allowing for a kind of freedom to enter into the picture of how we think of our biology. Genetic determinism makes it sound like we are Cartesian machines, exactly, and we have a clockwork, exactly, and we kind of work. But my question is there now a room for determinism to come from another side, namely the environment acting upon us?
Yes, but now let's have a look at that, because you see that's stochastic as well. I agree with you. Yes, you could say that the environment is itself determining what we do. Now, I think that's partly true. Clearly, I've become the kind of person I've become through my history. So in that sense, it must be the case that the environment is a big influence, just as genes are. You see, I don't deny that genes are influential. I just simply say they're not causal in the way that we can be as agents. They're not causing my selfishness. They're not causing other forms of my behavior. Now, the way I think to think about this is that once you can harness chance, use it, you have the possibility of creating novelty, and that's what we're doing. And isn't that what we call creativity? You see, before a Beethoven emerges, we couldn't have predicted. I don't think musicians before Beethoven would have predicted what he did. He turned the apple cart around and came in with bum, 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 and all the rest of it, you know, and turned music upside down. And Einstein did the same with physics, fundamental physics. I think what those people were doing was to find the chance processes within themselves, seeing it, and then saying, oh, I want to go that way. That's going to shock the world. and they go for it. Now, sometimes they're wrong. That's fine too. That's how science, music, poetry, and so on experiments and finds its way forward. If we didn't have people who were wrong, we wouldn't be where we are. So we have to encourage that. But the process, I think, is within ourselves, and it's based on the fact that we are not determinate like computers with silicon chips that are rigid. I sometimes think of it like this. If I met a robot that looked very much like a beautiful girl, and everything went fine together with her and me, but then I discovered there was a big problem. I couldn't work out why she doesn't seem to know where she's going. What's her purpose? It's as though she's being programmed by Google to be the best person to satisfy all my wishes. But if that is all that it does, the robot, it gets boring after about 6 months, you see. And then I asked the question, but how does the robot see it? Could we imagine how the robot would see it? And I think what the robot would say would be roughly this. Oh dear, I'm made of silicon chips. My molecules, yes, they vibrate a bit, but they don't move around. He's made of water. What happens in water? The molecules are moving around all the time. It's Brownian motion, which we've known about ever since about 1830. So she's frustrated. I wrote a story like this. That's why I can repeat it here, because it fascinates me, because this will come. AI will get to the point where we will be able to create simulations of us. Well, ABBA have just done that in their magnificent performance 40-odd years later. So we will get to the stage where we can recreate this kind of almost human activity. How would we know there's a difference? And I think it would be illustrated quite well with the story I'm telling you, which is that the poor girl in the story would be saying, look, this is terrible. I know I cannot harness chance in the way he does. You see, the reason I can produce all kinds of variations is that my creator built a random number generator inside me so that I don't always do the same thing. But that isn't the same as him, because he's got a purpose. That's the difference.
Speaking about the future and sort of AI and a post-human future perhaps, what do you make of things like CRISPR and human enhancement through manipulating of our genetic material? Are those sort of efforts misguided, given your views about the role of genes in shaping our behavior? How do you...
Yes, first of all, CRISPR is very interesting indeed, because I think it illustrates the point that there is natural ways in which organisms can change their genomes. What does CRISPR do? It does precisely that. And the bacteria from which it was taken do it all the time. So that's the first point. It actually illustrates part of what I'm saying, that we, organisms, are capable of changing our genomes. But when you come to the question, could we use it to, as it were, deliver the promises of the Human Genome Project, even though they've not yet produced it? Because we can say, okay, if you could correct this gene, would we have the future reassured, and we can then avoid all of these diseases? I very much doubt it, and I think it's very dangerous, because we do not know the function of all genes. Most genes, in any way, contribute to many functions. So when you manipulate this one because you know it produces this disease, what else are you doing? And if we don't know that before we use CRISPR, how do we know that modifying the germline, because that's what it amounts to, isn't going to produce problems in the future? So that's why I say that I think it's dangerous. We need first to know more about the functions of genes in general in cooperation with each other, because they tend to work in cooperation with each other rather than as isolated elements in the system. In that case, we need to know that before we interfere with that system. It's like a watchmaker suddenly saying, well, I'm going to fix this watch by bashing this cog and changing it this way, without understanding the finesse of what has been created.
What do you think the biggest question in molecular biology is these days that people aren't paying enough attention to and should be?
I think we have to get back, I'm sorry to say this because I am a physiologist, we need to get back to a physiological interpretation. Now, I wrote an article just 2 years ago together with a colleague, and I called it, "Could Physiology Rescue Genomics?" I think we can. We can identify where there is causality even when it's not shown by the association levels. Now, I've explained that in the case of the heart. I can do the modelling and I can demonstrate it. And we did the experiments that are the basis of the model. I think that could be done much, much more. And the database to do it is already there because we have hundreds of physiological models now on a site which is called the CellML, it's a technical term, website. So we have many of the causal models in place to simulate what the biology is showing. We could easily, well, I say easily, it takes good mathematicians and programmers to do it, but we could work out why this gene association is so low, and then ask the question, what would be a better way of intervening in this system, this control system? So I think that physiology could come to the rescue of evolutionary biology.
So a more holistic approach to the organism rather than a reductionist one?
I'm afraid we have to, because reductionism has failed, yes.
Denis Noble, thank you very much.
My pleasure.
For more debates, talks and interviews, subscribe today to the Institute of Art and Ideas at IAI TV.